here. So I wanted to make a quick disclaimer before the video, just to say that I am still a student, so mistakes are possible. And I want to make this very clear when I say that even though I'm studying at McGill University, the content has not been backproof by somebody from it, so they are really separated from, they're not affiliated. Okay, so I'm the sole responsible for what you're about to see. So if there's anything, any inaccuracy, I want to excuse in advance. Otherwise, I hope you enjoy.
Hi, so my name is Ellery. I'm an occupational therapy student here at McGill University, and for the purpose of my learning, I wanted to talk to you about stroke. Not the symptom, not the consequences of it, which everybody knows. I want to talk about what happens in the brain. There's 3 types of stroke. There is the embolic stroke. It's a clot coming from elsewhere in the body. There's the thrombotic stroke, which is a clot forming inside the brain. And there's the hemorrhagic stroke. It's the one where there's a vessel bleeding. So here is what would happen with an embolic or thrombotic stroke. The blood flux is now stopped. And in the case of the hemorrhagic stroke, well, the blood is flowing out of the vessel. When that does happen, the cell, the neuron, doesn't receive enough oxygen and glucose. When that happens, the cells will recruit an enzyme that we call caspase-3. Okay? The cell will kill itself from the inside out. And what's crucial about having oxygen and glucose, it's that it's create energy for your cell to be able to properly function. Without oxygen and glucose, sugar, I'm going to repeat myself, sugar, your brain cannot function. So, let's come back to a stroke. When you have a cell dying, okay, you will need somebody to clean up the mess, okay, the waste. And that is the job for the glial cell. In our brain, we do not only have neuron, but we do have another type of cell called glial cell. It's like the scaffolding, holding everything together and helping the brain function. So they are not really round, but for the purpose of today, let's just assume they are. So you have the glial cell coming in. Then, when cells are dying, glial cells are taking the place, and that will actually create what we call glial scarring. It will take space up. And as it does, it will compress neuron nearby. When neurons are compressed, they too like oxygen, so they too will die. So other neurons are dying because of glial cell scarring. Okay? The initial cell dying because of the lack of oxygen due to the blood vessel injury, the stroke, it's what we call primary cell death. But when it's caused by the glial cell, it's what we call secondary cell death. And throughout all of this, when every cell dies, whatever the moment, they release glutamate. The neuron will release a neurotransmitter, glutamate, and this neurotransmitter excites other neurons around. It creates what we call excitotoxicity, and this will also lead to more neuron dying. So here, other neurons are dying. Okay. Now, it doesn't happen with every stroke, but it happens with hemorrhagic stroke when there's a blood vessel that has ruptured. You will have the immune system that is called to help to the situation, okay? There's many agents and cells that will come by. There will be edema and inflammation, just as you would have with a wound, a scratch that you have on your knee, on your forearm, okay? So there is inflammation in your brain. When it's on the outside of your body, it doesn't cause problem, but in the brain it does, because there's no place for the brain to swell. So then there's more compression, more cell dying. Only in the case of an hemorrhagic stroke. So this is why a stroke is so not fatal, but so grave, so impactful on somebody's life, because cells are actually dying inside the brain.
Well, I hope this helped. I hope you learned. And if you did enjoy, well, please interact with the video by liking or even subscribing. Thank you.